In analytical geometry, we are going to be looking at various concepts, and one important one is first, how are we going to be able to analyze various systems when given a specific graph? Usually, you're given a graph that is two-dimensional, but there are other cases where it is three-dimensional, and in here, we're going to basically look at two-dimensional systems where we have our Cartesian plane. This is a y labeled and this is our x labeled. Take note that in here for our x, we usually call it the x-axis, and it is also called ABSCISSA, Abscissa or Abscissa. Let's see how it's pronounced here. Abscissa. Yes, that is perfect. And why the y is called the ordinate. So, for example, if you're asked here that, hey, if you have a rectangular coordinate, how are you going to be able to showcase these on this particular system of graphing? A rectangular coordinate implies that we have a specific point on your graph, and this point always aligns to two directions. One is pointing to the x, which is in this case x naught, and the other part is pointing to the right or towards the y axis, and this here is highlighted as y naught. So therefore our x naught comma y naught is a coordinate point, and this x naught is called abscissa and the y is called the ordinate, and this is observed in a standard two-dimensional system. Now let's move on and see how this is going to look like where we have 2 points on the graph. So now we have a graph with our y and we have our x, and so where we have a point that is right here, another point that is right here. What we notice is that first we need to be able to assign this as, moving from left to right, p naught and p subscript 1, which means that p naught is point that comes first and the point that comes later is p1. So p naught here has the coordinate that is assigned to be x naught y naught, and y the coordinate for p1, of course you should recognize it to be p1 y1. You can also highlight p naught as the initial point and p1 to be the final point. So whichever way works for you, that is absolutely perfect. And next up here is to be able to connect these points together with a straight line touching one point to the other point. And so by doing this, we can now challenge ourselves by determining the distance from point naught or initial point to the final point. And to achieve that, we need to be able to look at two pathways that leads us from point initial to p final. You can actually go this way, which is you go distance up and then move to the right. That is one way of approaching that. The other way is by moving all the way to the right first, and then you align those way up to P1. So those are the two ways. I'm going to choose the second pathway, and the second pathway is identical to the first pathway, but in the other case we are highlighting which one we're starting off with first. Either ways, moving on, we need to recognize that for our horizontal trip, first we need to consider the distance. That means we need to highlight from P naught x to P1's x because we are dealing with the horizontal. Therefore, we have our P naught, which is the x, and we have our P1's x, and therefore the difference between these squared, which is giving us the magnitude of this length here, will enable us to determine what this value is. And we're going to do the same thing but for the y, and so in here is our y naught, and this here is our y1. So therefore, when we are going to be determining our scale, we need to recognize that this from here to here is equal to the absolute value of x1 minus x naught, and this is for the y is equal to absolute value of y1 minus y naught. This is also stated as the magnitude of the x change, and this is highlighted as the magnitude of the y change, and therefore we can determine our d, which is expressed as the distance between P1 and P naught. And to address our d, you recognize this to be Pythagorean theorem, because in here we have a right angle that is showcased here, and this leads us to what our d is, where d is equal to, or you can say d squared is equal to the magnitude of our specific x, which is in this case x1 minus x naught, all squared, plus our distance between P1 and P naught, which in this case is y1 minus y naught, all squared. And this will lead us to our final step, where you perform the square root of both sides. We have our d to be equal to all square root of our square of x1 minus x naught, and this you add it to as all square of y1 minus y naught. And this is how you're able to not only determine the rectangular coordinate, which is wherever you're given just a coordinate point. This is how you locate it on a graph, by figuring out where the x is first, then trace it to where you stop for the corresponding y, and that gives us our naught, which is in this case called the Abscissa ordinate. So that is one to keep in mind, and the other one here is to be able to determine the distance formula, which is expressed as this right over here. Hope you found this really informative. Let me know your thoughts about this in the comment section down below. That way I can reach out to you. Subscribe, that way I can talk to you very soon. Stay smart as always, and believe in yourselves.